Hey everybody, welcome to today's online training, Intro to K3s. We have quite a few people joining the line, so I just want to take a moment while people are joining to let everybody know that this session is being recorded. We'll go about an hour. We have an hour and a half scheduled. We have plenty of time for Q&A and all that, but if you do need to drop, don't worry about it. This session is being recorded and we will send you the recording and the slides after the training. So now that people have joined, why don't I go ahead and get us started? We have a lot to cover. Just as a way of introduction, my name is Matthew Shear, marketing manager here at Rancher. I help host a lot of these training sessions. We have more on the calendar, and I'll talk about that in a bit. And I also included my contact info, email matthew@rancher.com, and on the Rancher user Slack, I am at Matthew. Please reach out to me. I'm happy to be your point of contact if you're looking for resources, you have questions, or the recording doesn't get your way or something like that. And I'd also love to hear from you if you are using Rancher, if you are using any of this software, if you're having trouble or you're doing something really cool. We would so love to hear your stories and know what you guys are all doing with this stuff, since it is open source and it is just out there in the wild. So feel free to reach out to me. I'd love to chat. But the person who's really doing the heavy lifting today is going to be Mark Abrams, field engineer. Mark, are you there?
Hey, I'm here. Hello, everybody.
All right, rock on. Well, I'll let Mark introduce himself a little bit more as we get going. Just a couple other groundkeeping items, sort of house rules. This is a K3s intro training. We are trying to keep this to an hour, but we can go long if need be. We do our absolute best to respond to every single question that you all may have. If for whatever reason you want your question to be private, just let us know. GoToWebinar has a cool chat feature, so just enter your question in the chat, and I will see them. We'll take a couple pauses here and there during the training for questions, and then leave a lot of room and time at the end for just extended Q&A. Like I said at the beginning, the session is recorded. It'll be posted on YouTube. We have a ton of other training sessions on YouTube as well. Everything is there for you all to enjoy. So do check that out if for whatever reason you don't see it on your email or you want to look up a different topic. And more resources, probably a lot of you are already using these, but if you're not, I highly recommend you join. It's all totally free. Our Rancher user Slack, so slack.rancher.io. Thousands of members, hundreds of people every day asking and answering questions. Our engineers are on there too, checking those out and escalating questions internally as needed. There is a K3s channel, just pound K3s, specifically for K3s discussion. And then longer form announcements and posts are on our forums, so forums.rancher.com. Again, just great free resources for the community. And finally, there are a lot of other upcoming classes and trainings that we offer. If you are brand new to Rancher, I highly recommend tomorrow's session. It is free, it is just live, and there'll be live Q&A, and that is on an intro to Kubernetes and Rancher. And then every month we do an online meetup where sort of a whole community gets together. There's usually hundreds of people on and just tons of questions. We talk about the latest and greatest in Rancher, and what's going on around the cloud native landscape. So that's January 22nd. Please check that out. And then after that, the next week, we'll just continue to focus on security with a masterclass by one of our principal software engineers, Prachi. It should be really good. So check all those out. This slide, this deck will be sent to you all, so you'll have the links and you can sign up as you want. All right, now that all of that is out of the way, I'm going to pass this over to you, Mark, make you the presenter so that you can get us going.
Great.
All right, I'm making you the presenter.
All right. Let's see. Can you see my intro screen
here?
here?
See your slide. You're good to go.
Okay. So for today's masterclass, we're going to do an intro to K3s. I'll go over some of the fundamentals of K3s. We'll have a demo of K3s on a single node, and then we'll get into high availability, and I'll do an HA a demo of K3s in HA mode as well. And then I'll take some time to talk about use cases. Now, if we have time, we'll get into multi-cluster management and how we can view clusters, multiple clusters from a single pane of glass. That is Rancher. I'll do that if we have time. Again, my name is Mark Abrams, and I'm a field engineer with Rancher Labs. I have been with Rancher for almost a year and a half now, doing field work with a lot of different customers in all areas of business. Get to learn lots of interesting things that people are doing with it, trying to do with it out in the community. I present at various events. Last year, I was at the Open Source Summit and at the ARM TechCon, as well as some local regional stuff as well. So with that, let's jump right into some of the fundamentals of K3s. And let's start with the Kubernetes architecture, right? Because K3s is a lightweight Kubernetes. So we have to look at what is Kubernetes and how did we get to K3s. This is a diagram that comes right off of the kubernetes.io site. And it shows the component parts of Kubernetes and what it takes to run Kubernetes, basically breaking it up into what Kubernetes calls the masters and the nodes. The masters typically have the control plane and the data plane. You may have seen installations where these are even separated out into different servers. But this is the general architecture that Kubernetes shares with us. So the components here are really, I think everybody knows these, but I'll just go through them real quick because this is sort of what really gets interesting with K3s is how K3s manages what we did with these component parts. So the API server, of course, is the front end for the control plane. etcd is the data store for the cluster. The kube scheduler selects nodes for newly created pods to run on. So based on hardware, software, policy constraints, the scheduler is going to figure out where to put the pods. The kube controller manager is actually a single process of multiple controllers. So it's the default controllers that you get with Kubernetes. You can, of course, create your own as well. And then the cloud controller manager is actually cloud specific. It's cloud provider specific control loops that are in the cloud controller manager. And then over on the right-hand side, you see the node components, and that includes the kubelet, which is basically a node agent that ensures that containers run inside a pod. So if, making sure the pod has all the containers it should have. The pod, of course, is not on this picture, but it's the smallest deployable unit that can be created and managed in Kubernetes. And then there's the kube proxy, which basically maintains the network rules on the node, implementing a part of the Kubernetes service concept. As you know, you can also create, a CNI, a software-defined network. You can add that on as well and create the pod networks through that. And then, of course, what you don't see here is the container runtime. Underneath all of these things, the kubelet and the kube proxy, we require some sort of a container runtime. And the default with Kubernetes, with many Kubernetes installations is Docker, but it's not required. So with that, let's take a look at the K3s architecture, which has many of the same components, but it's different in a lot of ways. Now we break out these component parts into the K3s server and the K3s agent. These are similar to the master and the node that Kubernetes refers to. And you can see that there are many of the same component parts. We have the API server, the scheduler, the controller manager, and that's in the K3s server. You'll notice etcd is not on the server, so that's something we'll talk about. And then on the agent, on those nodes, you'll notice that we've got the kubelet, the kube proxy, and a container runtime. We're using containerd here. Let's talk about so each of these can run in their own process, and that's something a little bit different than we have in straight up Kubernetes. So whoops, let's go back one page. So in Kubernetes, we run each of these things in independent processes, the kube API server, the kube scheduler, the kubelet. And so K3s is doing something different here because it's running this single process that runs all those components. In fact, you can run a single node K3s that has both a server and an agent component combined together. And these two processes actually will be run in a single process. So what did we do to get Kubernetes into such a small footprint? One of the things is we removed the dependency on etcd, and you can see that here where we have SQLite. So the dependency on etcd allowed us to run a single node by having a SQL database instead. But we did some other things, and I'll talk about those later, why the SQL works in this scenario and how we did it. In addition, so out of the box are the initial version of lightweight Kubernetes K3s had a low memory footprint, could run in less than 512 meg of RAM. All the components were in a single binary. We deployed it with multiple architectures. It was important based on the landscape and the interest for a lightweight Kubernetes that we were deploying to both ARMv7 and ARMv8, and as well as x86. And we deployed out of the box with an Ingress controller. We removed the dependency on Docker. As you saw, we have containerd instead of Docker. And then we removed the dependency on etcd, which is where we put in the SQLite instead of etcd. Overall, we removed about 3 million lines, probably about 1 million lines of code. And that included entry storage providers, entry cloud providers, alpha features, legacy and non-default features. And so part of how we got here is we were working on another project, and in that project, the developer was kind of frustrated with the complexity of Kubernetes and really just wanted the Kubernetes, the fundamentals, right? He didn't need cloud providers. He didn't need storage providers out of the box. And those things are in the source tree, but initially we stripped those out. So I'm going to show you now what this looks like when we run it just as a single node. So I'm just going to download the binary. We'll run it. It's actually kind of boring. It's very simple. So let's see. We're gonna do a curl command, and we'll go ahead and get this from the web. And actually, I can show you. Let's see. So this is the K3s site on GitHub. And if you go into the releases page, you can see that the version 1.17 release is the latest release, right? And if we scroll down here, you can see that we've released it for ARMHF, that's ARMv7, ARM8v8, as well as the AMD64 and the x86 packages, essentially, which is this is the x86 package right here. K3s. So I'm going to run this. Let's take a look at what is this. So everything I'm running today is Arch64. It's all a bunch of Raspberry Pis I have. So this is a Pi 4B Plus, and you can see it's Arch64, so it's running 64-bit Linux. And if we do cat, let's see, OS releases, you can see I'm running Debian Buster essentially. This is a Raspbian version of Buster. Okay, so I am going to run this command. It's a curl command, and I'm going to just basically download. That's the link. If we go here and we you know, get the link address, this is what it'll be. I've added so the L command says follow links. So if there were any 301s that redirect me to someplace else to download it, that'll take me there. The -O says download it as K3s. So before I do that, let me, oh, and I'm going to turn on my keycaster so you can see what keys I'm hitting as we go through here. So, so you can see this is just a straight up, it's actually a Raspberry Pi desktop. It's not even light. I've got a TFT display attached to this thing. And so I have nothing here, and we'll put this back in. And we'll just download K3s. Pull that down. I'm not sure why Keycaster is not casting right now. I don't see the keys coming up. Okay, so we have it. Great. So now I'm gonna right. So I'm gonna look at it's not an executable, so I'm gonna change the mode to executable, and then we're gonna run it using sudo. We'll run the server. There are a ton of options that you can run. We'll create a log file of the output, and we'll run it in background mode. So that's now running, and now I can run K3s kubectl get node, run any kubectl commands, and it might take a minute for that to come up. There we go. So I have a single node, and oops, get, oh, my keys are not, what's going on here? I seem to have lost access to that device. All of a sudden, my commands are not getting entered. So fortunately, we can see that we did a kubectl get node and it works. So let's go back and take a look at where we're going to go next. So that was, like I said, it's very simple. You might be saying to yourself, well, why would I do that instead of running micro-K3s or Minikube or something like that? And the reason is that, well, K3s is designed for production. Our intention was to build this as production Kubernetes. Micro-K3s and Minikube are really designed for the developer. You can run a single node Kubernetes cluster, which is basically what we just did, but we want to go beyond that. And I could connect nodes to that cluster that I just stood up on that single node. I could attach worker nodes, but we might even want, you know, a highly available data, you know, etcd type data store. It won't be etcd in the K3s case, although it could be. We allow that too. So we're very flexible. So what we did when we did GA, our version 1 release was around KubeCon last year, and it had all the things that we just talked about, the low memory footprint, the multi-architecture distribution, but we added out of the box a Helm controller, so you can drop in into a directory with the deployment. You can drop in a Helm chart, and it'll automatically install that chart. We had deployed a service load balancer. As I said, we took out some of the cloud entry cloud provider stuff, but the really important thing here was, load balancing. That was what we felt was the key piece. And then the other thing was the adding a local storage provider. So you can actually set up local storage. It actually by default sets up a local storage provider on every node. You can disable that. All these things can be disabled by, if you don't want them by default. But the local storage provider gives you local storage out of the box. So if you have PVCs, they can pick up the default volume from local storage. Obviously, you need a pretty good size system to do that. We also expanded the data store options. So we had embedded SQLite, and that's how we were able to get rid of etcd and get rid of the need for 3 nodes. But we of course wanted to have something highly available. What we really did was, it was a process. So we weren't just getting rid of etcd. We were remapping the interface for etcd and remapping it to SQL backend. So we built something called Kine, Kine. Kine is not etcd, and we mapped that interface, the API, to other data stores. So in theory, Kine could be mapped to any data store. And now you have that etcd interface for Kubernetes, which Kubernetes requires. But instead of talking to an etcd data store, it's talking to a SQL data store. And in doing that, we were then able to slip in any external database as the back end. We started with MySQL and PostgreSQL. We'll take a look today with MySQL as an external data store for HA. And then we added some documentation around how to do air gap installation. As well as giving you the capability through basically text files that contain the content of what needs to be pulled down into your air gap, pre-pulled, so that when you actually do the installation, the images are available and there. So let's take a look. Let's move on to what the architecture looks like with the high availability mode. You've seen this slide. This is the slide I showed you before with SQLite. But then when we went into an HA version, we actually said, okay, well, let's pull that external SQL database out. Everything else stays the same. One thing that I forgot to mention here is this tunnel proxy. So Kubernetes, the kube proxy talks to the API server, and you could have an external client that talks to the API server as well. But when the kube proxy talks to it, they actually use a number of ports for communication in a pure Kubernetes cluster. And so what we did is we built this tunnel proxy so that there's this initial one directional communication from the kube proxy to the API server. Once the kube proxy reaches out through this tunnel proxy to API server. Once the communication is established, they can talk and have bidirectional communication, but it requires then only one port be open. So it reduces the footprint and basically reduces the security. It increases security by reducing the accessible ports on a K3s installation. Okay, so here we have the external database, but in HA mode. But what we'd really like to do is keep the simplicity, right? So this requires that I manage an external database. And we'll talk about that a little more in the use cases. But what we also wanted to be able to do was do an HA mode with an embedded database. So we started looking at SQLite, which is distributed SQLite. And we're pulling that back in right now. You can actually try this out. It's experimental on our on the K3s site. There is instruction in the docs on how to use it. We're going to eventually get to a point where we release with SQLite as part of it. So what's the difference between SQLite and an external data store? The difference is that with an external data store, you only need 2 nodes because you're talking to a single database, and those 2 nodes would constitute HA state. The thing with SQLite is that we're still using the capabilities that etcd had that allowed it to be highly available. And in doing so, it requires that you actually have 3 nodes. So for the embedded SQLite, you'll actually need 3 nodes to have an HA installation. So all these options now, easy to install, but depending on your use case, that'll dictate which one you choose and how it drives what you're going to do with K3s. So some of the requirements for running K3s in HA, you need unique host names. If you don't have unique host names, let's say you have a bunch of Raspberry Pis, you have an SD card image, and you don't change the host name on those, you could still run this. Of course, you're going to be addressing those with IP address to shell into them for SSH, but if you add the -- node name flag or the environment variable K3s node name, you can actually get K3s working even though they don't have unique host names in your environment. In addition, we're testing on Ubuntu 16.04, 18.04, and Raspbian Buster. As you can see, I'm running on ARM64. It's not in our test suite. If you're looking for support and it's something you really need, talk to us. We can provide that. We can talk about providing that. I'm sure we can figure something out to get ARM64 into the matrix, the test matrix. So K3s HA requirements continued. The hardware, again, it's still a minimum of 512 mega RAM, 1 CPU, and then we recommend SSDs. And just like etcd, the high IOPS is going to give you better performance of your Kubernetes installation, your Kubernetes cluster. In terms of networking, we need 6443 open. If you're using Flannel out of the box, we have Flannel. If you're using it, you need 8472 open. If you're using the metrics API, you need 10250 open. And that's pretty much the basics of the requirements. You can, of course, go and look at the full requirements on the docs page as well. So here's K3s HA with a 2-node minimum and an external database. Pretty simple. That's what it looks like. In this scenario, what I'm showing here is a 2-node Kubernetes installation that's highly available, where we're using an external database. All nodes have all components. They have the data plane, the control plane, and the worker role. We can also do the separate masters, right? And so this is a little bit more like that yellow diagram where I've isolated the K3s agents from the K3s masters, the servers and workers in this case. You'll notice that not only do I have an external database for the servers to store the Kubernetes cluster data, but I've got a fixed registration address server. In today's demo, I won't set one up. This will add a layer of complexity that it may or may not be necessary. So I can point my workers. So what I need is for my workers to initially register with the cluster in some way. I could point to the IP address of one of the servers or to the host address, the host name of one of the servers, the FQDN, or I could have this front end server that has a fixed registration address. Maybe it spans all 3 some sort of a reverse proxy or a load balancer. But then I need to make sure that my fixed registration server is available at the time when I'm trying to register workers. So it might also need to be created in some HA mode. So that's why I say it adds complexity. But you can do that if you want to. All right, so let's get down to business here. Let's do a demo of highly available K3s and what that looks like. All right, so here I have my panes split up. Let's take a look at what I've got here. So you can see I've got another Arch 64 system. And in this case, I've got a Fedora 30 installation, Linux installation. So this is master 1, and you can see right below it is master 2. Both my master nodes are running Fedora. There's no there's no significant reason why I'm doing this. I had originally, when I was trying to work on getting Arch 64 working, I initially started with a Fedora image. And so I had a couple of Fedora images already available and just kept using them. But there's no other reason than that. It's not, it could also run on the Debian images as well, as I showed you in the single node. Now, on the other one, so those two nodes are Raspberry Pi 3B plus, and actually let's go back up and we'll do an HTOP on these. Did I install HTOP? I did. So you can see that in this case, I've got, oh, it's not showing how much memory I have available. Interesting. So these have 1 gig of memory, and if I recall, this used to show the amount of memory. I'm not sure what changed here. But anyways, so you can see that I have 4 cores. I do have a gig of memory. Swap is turned off, and basically in the memory, I don't know if you can distinguish colors as this comes across to your screen, but there's about 8 green bars at the beginning. That's used memory, and then the blue is buffers and the yellow is cache. So you can see even with cache memory, not a lot is going on this system right now. Let's get out of there, and we'll go down and we'll take a look at the B plus. So I've got a 4B plus here. Again, running Arch 64 and running Raspbian Buster, and you can see again, not much going on, a lot less usage. This is a 4 gig device, so much bigger device. And then finally, let's go down here and we'll just run HTOP. This is also Arch 64, also Raspbian Buster, and in this case, this is actually 512 mega RAM. This is a Raspberry Pi 3A plus, so it's a very small device and a lot smaller form factor than the other ones. But I'm gonna pull these all together and make a Kubernetes cluster out of these. So let's do that. So I'm going to start with installing just the server component on each of these master nodes. So here's a long command that I copied and pasted out of my notes. I'm pulling down the get K3s script. And if you just pull this and you can read it, but I'm going to pipe it through shell, and I'm going to add some environment variables along the way. So this is curl be silent and fail on errors and follow links. And then I pipe it into shell, but then I create, before I do that, I create this environment variable called install K3s exec. I set one called write kubeconfig mode. If you recall, when I did the, yeah, so we lost connection here. I don't know if we'll get it back. But when I initially did kubectl on this single node, I did it with sudo. And I did that because I can't access the YAML file the way I ran it. But there are command line arguments, and this is a command line argument for K3s that allows me to set the kubeconfig mode when I create it. Actually, 644 is actually not a good mode. That's the wrong mode to set it to, because that's going to make it world readable, and that's actually not what I want. Right, so that's the wrong mode. Because this is a security file, right? But anyways, the point is you can write the kubeconfig mode, and that'll allow me not to have to run sudo every time as this user when I run this. Then actually I'm going to go ahead and start this and on the next one, and then we'll take a look at it while it's starting to install. We'll continue to discuss what we're running. So I'm running it on master 2. And on master 1, we'll continue talking about what else I have here. I specify a data store endpoint. So I've created an external database. I have MySQL running in a container on this Mac laptop, actually, that I'm running. So they're all in the same network space. And so my data store endpoint here is MySQL K3s admin, and then I'm giving the parameters for password and user in that, and the database name is K3sDB. So that's what I'm creating. I'm creating a secret. -T is the agent secret, and that's the secret that I'm going to use with my agents to connect to this. So we're going to have this shared secret. You'll obviously want that to be secret and not shared with 30 other people in a demo. And then the TLS SON, I'm actually saying in my cert, make sure that, and this is actually a little bit, this TLS SON is not going to help me too much because that was when I had a registration server. So this is an old master 01. It's going to be wrong in the other one. But basically that's going to add to the cert. Since this gets stored in the database, we may have to go with what we had before. Not sure how that's going to work. That's something I should test out. The node taint, so I'm saying taint this node to be just part of the control plane. So nothing can execute here. So it's not schedulable in the Kubernetes parlance, meaning I don't want any worker, I don't want any pods deployed here, right? And then finally, my last environment variable is the version of K3s that I'm going to install. So we're going to go ahead and run that here as well. And we'll come down and do a kubectl. Notice no sudo and no K3s. The other thing I did in that that original one is you'll notice I ran kubectl as an argument to K3s. The difference here is on this single node, I downloaded K3s and I ran K3s directly, and I could create a symlink, a link, a local link to K3s, like an alias to K3s kubectl for the kubectl command, or a linked file But basically, it's embedded in K3s, right? That's the whole single process. Whereas here, I'm running kubectl independently, and I'm going to do a kubectl get node, and that's going to show me the nodes attached. There should just be one now. I'll do a watch on this, and we can watch these as they come up. Okay, so we have one node, and as more nodes join, we'll see additional nodes. So the next thing I want to do is actually join in my worker nodes. So I'm going to run it on the 4B plus first, and then I'll explain it down here. Again, you see I'm pulling this, it's the exact same script, but this time my environment variable is agent instead of server. I'm using that same secret, agent secret, right? And then I'm specifying, in this case, I'm specifying master2 as the server. This would be my registration server. In this case, I'm just specifying this server here. Oh, look, that node came up. So I now have a worker node that's joined as well. It doesn't specify the role. You actually have to label those if you want those labeled. There comes master1 as well. So now I have two masters and one worker. Let's get this other worker installed. The final thing is the K3s version. And again, I'm installing the latest K3s version. So we'll get all those nodes to come up, and let's do a quick take a look at what pods are there. All right. So we've got all four nodes are in now. So I now have a Kubernetes cluster. And you can see that we've installed traffic. We've installed core DNS. We've installed the metric server. There's the local path provisioner. And some of those things have not actually come up yet. Let's do actually a -o wide and see what node those are running on. Everything's running on the 4B plus, which is the node with lots of memory, right? So Kubernetes is kind of doing its thing. Looks like traffic is having some errors coming up. But Kubernetes is doing its thing, right? It's looking at the resource pools and it's going, hey, this node has a lot of resources. Let's run everything there. All right, let's get back into the deck. So here again, and I did this just so you have this when Matthew sends out the deck. So here's setting up the master without the agent. Please refer to the GitHub page and the docs for all of the things you can do with K3s, all the flags and the parameters and things like that. That's the server. This is the agent. Basically, then the other thing is, this is the setup, the configuration, right? So this is what it looks like on my laptop. I've got that SQL container, and I've got my two masters, which are Fedora, the 3B plus Pies. I'm doing registration. I'm not going through a registration server, but I have to do registration. And then kind of what this doesn't show is that proxy server that opens up once registration is done, the communication after this initial registration goes through that proxy server. And then I've got my two workers in this case. We often get the question, can I run both? Can I run ARM x86 and ARM simultaneously in the same cluster? Absolutely. Kubernetes doesn't care. It doesn't really know. It's just that your workloads need to be configured for the resource type that you have available, right? So if you have an architecture, your containers have to be built for that architecture. I want to get into some use cases and show you a little bit about what are people using K3s for. People are using them, as you might imagine, edge devices and ARM. That's partly why a lot of my demos are on ARM. The edge is the majority of edge, what we call edge now, is ARM devices. CI/CD. We're seeing K3s actually in the cloud and data center as well as on the developer desktop. Let's drill down into each of these. So for edge and ARM, we're seeing edge gateways. Software developer network compositions. Also machine learning before the cloud. So right now, the edge compute has been done in the cloud, and the gateway's been used to just do a protocol translation. So going from whatever protocol the edge nodes are speaking to HTTP, sending things up to the cloud where data can be processed, it's actually onerous. It's very heavyweight. There's a lot of push to move the process, the actual data analysis down into the edge. Right now, we're seeing it at edge gateways. We will likely see it actually deeper into the edge as well as those devices get more compute, as FPGAs become more prevalent, as the ecosystem is changing. We're also seeing K3s in branch management servers. So in stores, retail outlets, where you may have multiple retail outlets, tens or hundreds of stores that need the same product, but they all have somewhat different configurations. So they're creating, K3s provides an environment for turnkey operations where I can just send this to the store, plug it in, flip a switch, turn it on, go to a website that it hosts, enter my code, and it will pull down whatever configuration I need. It'll auto configure the system. Now the home office now has telemetry into these multiple branches. They can now introduce HA operations in places where they had single servers running, just file servers, applications for processing POS data and stuff like that can all be done now through containers and sort of, I think one of the common themes across all of these things is the consistency of development. So now if you're developing for cloud, you can have a process for deploying in containers, and the same goes for edge. You can now deploy to edge in the same way. The far edge, maybe we're still seeing firmware updates and that sort of thing, but even there, in far edge on, for example, windmills, which are little micro data centers, really. They're doing containers and data processing there for on-site data processing. And then field operation data centers. So we're seeing mobile AI units in military applications where they need to process data. They strip a laptop from some operative and they need to process it right away. Energy, remote operations, they need to do geolocation, geosphering, positioning, all sorts of interesting things, and they have little data centers operating in these rigs as well. And then in shipping and in actual physical ships have data centers as well. So those are some of the sort of the edge locations and types of use cases we're seeing. And then from the CI/CD perspective for CI pipelines, really just being able to automate environment up down just for the purpose of integration and testing environments, load testing, scale testing. Basically it's really mostly the CI aspect at this point, where obviously CD is delivery into your production systems. The cloud and data center, we're seeing a lot of just generally simplified installation of Kubernetes, where it's Kubernetes, right? So do you need full-blown installations? You might still want to do that. We still have a distribution called RKE. That is the most used distribution. I think it's the most used distribution. I could be wrong by Rancher. Certainly, it's used by the Rancher management server and many Rancher customers. But K3s provides simplified management in cloud and data center. Part of that is that you don't have the overhead of etcd, and so this third bullet about relational database solutions being well understood. Now you can basically say, well, I've already got, I have licenses for relational databases. I have staff who understand how to use them, how to create failover. I know how to do encryption at rest. I have DBAs that know RDB. And then the other thing is just generally many small clusters, and sort of how easy it is to make ephemeral clusters with a solution like K3s. Finally, for the developer desktop, you can now, again, coming back to the micro-K3s and Minikube, as a single node Kubernetes, you couldn't really do true Kubernetes orchestration between nodes, right? Now with K3s, developers can really actually do that. You really get this sort of easy to up and down Kubernetes cluster with things like role-based access control. If you're developing CRDs or you're developing Helm charts, you actually have a place to do this that's not a public Kubernetes cluster or a private one in your enterprise, but where other people are using it. So you can really take it to its limits with K3s. So we are, let's see, we still have a little bit of time. So I think what I'd like to do is we could open up for questions. I don't know, Matt, how many questions we have outstanding right now. And then I can come back and sort of demonstrate using this with Rancher and the multi-cluster management capability.
Yeah, cool. Thanks, Mark. So there's about 10 questions asked at this point. Maybe let's go through those, and then we can do a little bit more demo. Does that sound good?
Okay, sounds good. Yeah.
Okay, cool. So I'll just do the first asked first. So this is from Mete. I'm sure I'm butchering your name, but he asks, could you elaborate on how K3s is different to recent projects by the Linux Foundation like LF Edge and Project Eve or EVE?
Yeah. That's a great question. So the LF Edge, I don't, so I'm not sure I know Project EVE. It's been a while since I've looked at LF Edge. So K3s is a Kubernetes distribution, and I know that some of the projects within the LF Edge space are really designed around process and sort of if I am if I am going to build an edge gateway, what is the template for building that? I'm afraid I don't recall which product is which within LF Edge. So the best thing I can say is that K3s is a Kubernetes distribution like kubeadm, kubespray, RKE. And so when you're looking at those other projects, most of them use they are using a Kubernetes distribution, but they are not themselves Kubernetes distributions.
Right, makes sense. Thank you. Okay, here's the next one. This is from Sorim, who asked us when you were doing the K3s install near the beginning, and he said, why do we need sudo?
Well, so I started K3s with sudo because I needed elevated permissions to run K3s. But when I installed it through this process through the single node, I installed it with sudo, but I didn't do anything to give myself access to the kubectl to the kubeconfig file. So I could run K3s. Let's see if I can log back into this device. It may not have come back up. I probably have to restart it. So I could run K3s sort of without sudo, but because I started it with sudo, I needed sudo to run the other operations. You'll notice over here, I did not run K3s with sudo, right? But under the hood, we are getting elevated permissions to install some components like into systemd. You can see here, we actually installed a systemd service. So I would need sudo to start and stop K3s, but for just running like kubectl commands, I just need permission to use the kubeconfig. I could generate, using RBAC, I could generate kubeconfig for a user, and then that user would have the standard Kubernetes permissions.
Awesome. Okay, thank you. All right, here's the next one. This is from Hans, who asks, how do I upgrade K3s to a new version from 1.16 to 1.17, for example? Are there any risks?
There might be risks depending on what what version you're starting with. I know that we are trying at this point, now that it's been GA'd, we are trying to ensure that the releases are at least one version backwards compatible. So for example, if I was running a 116 cluster and I had 4 nodes running on 116, I need to upgrade both my masters and my worker nodes. And I need to upgrade them one at a time. The upgrade is actually very simple. The upgrade, let's see if I can get into this now. So I don't know if I'll see, yeah. So I'm not even seeing the install command. Let's go back to the slide presentation. We'll go back a couple of pages. Hang on just a moment here. Let's see, here we go. Okay, so here I did this environment variable install K3s version. So you can upgrade to the next version just by changing that environment variable or using the flag on the command line when you run K3, when and basically do a reinstall. So if you're running it through this script where we actually install the init script into systemd, you would just change the flag. You're going to have to do one node at a time. They should be backwards compatible up to one version back. The challenge is going to be one stable version back. The challenge is always going to be if you installed an unstable version. So if you've been playing around with latest, but it wasn't marked stable, it may not be compatible, but it's hard to say. In terms of upgrading a cluster, I would start with the servers, do one server at a time, make sure that it upgrades. I should have, for my next demo, I'm gonna install an older version, then we'll do an upgrade. I think that's a great thing to do. Show you how to do that. But basically upgrade my server, make sure it upgraded, right? So I do one of them, make sure it upgraded, and then come back and do the next one. Then do my agents once the servers are upgraded. We could actually go in here. I'm not gonna. So I've got my 4 nodes, right? In this box on the middle box on the left-hand side, I've got the 2 masters and the 2 workers. I'm gonna stop K3s on this master. And that will drop it out of the cluster. You'll see that it's going to show as not ready in the status, right? And so because I have this HA mode, right? So now I can do this sort of thing where I can upgrade everything. This becomes a little bit more complex. You'll have some downtime. If you have a single node and you do an upgrade, you're going to have downtime.
Okay, thank you so much. Oh, were you done with?
No, I was going to say next question. Yeah.
Yeah, next question. All right, there we go. All right, here's the next question. This is from Sorum, who asks, who says SQLite is written in CIRC. Are you guys using CGO to get to SQLite? Why not RQLite, which is Go based?
That would be a question for the developers, and I would recommend using the K3s Slack channel to ask that question. I don't know why the decision was made to use SQLite, versus a Go-based SQLite.
Okay, cool. Yeah, makes sense. So yeah, pound K3s channel on the Rancher user Slack.
Yes.
Okay, let's see. So the next one, this is from Ludovic. I'm sure I'm butchering your name, but he says, with MySQL as the backend, could we have issues with bin logs like in Rancher 1 because of many updates?
I am not sure what the issues with bin logs were. So I just don't know the answer to that. I don't know what the problems were. If you're using MySQL as a backend, it is external, and so you do need to manage it independently of the Kubernetes cluster.
Okay, cool. Yeah, and maybe another good one for Rancher General or the K3s channel. So this is from the next question is from the same gentleman who asks, could we imagine running Rancher 2 on K3s?
What a great question. Yes, we can imagine it, and it is coming. We are targeting, I don't know what if we have a date set yet, but we are targeting running Rancher 2 on K3s. It would create a simplified installation of Rancher 2, which right now, for those of you who don't know, you need to install Kubernetes first in order to run Rancher. And this would be sort of all-in-one simplified installation.
Okay, cool. Thank you. All right, here's the next one. This is from Luke, who asks, why not use an RKE style installation?
Yeah, so RKE is the Rancher Kubernetes engine. It is a distribution of Kubernetes from Rancher Labs as well. And the RKE, I think what you mean by the RKE style installation is that we have a config file for RKE, and I can write all of my configuration into this YAML file, and then I point RKE at that config and say RKE up. I tell it what my nodes are and what the configuration should be for each type of node. So with this distribution with K3s, you're basically configuring each node at a time, right? There's no common configuration. However, you can use K3OS. K3OS is the K3 operating system, and K3OS has a cloud config, a cloud init config, which will allow you to configure the entire system and will install K3s into that container operating system. I'm not sure, exactly why it's done this way. I think, part of it is the simplicity of a single binary. You could absolutely write a script to install K3s, basically using Terraform or something like that to install K3s into your nodes. And so you really don't need that config file in the same way. You would be passing configure arguments as environment variables or parameters. But that's an interesting question. I haven't really thought a lot about it, but I'm not sure that K3s lends itself to the same installation model as RKE, where you kind of blow in a whole installation into multiple nodes at the same time.
Right. Okay, cool. Well, there's a few more questions. Do you want to take those questions, or do you want to finish that last portion of the demo that and discussion?
Yeah, sure. Let's have a little break. We'll go in and let's restart this. As you can see, master one is not ready. So I'm going to restart this node, and that'll come back up. And we'll have an HA cluster again. And then, so a little bit about Rancher. Rancher is, Rancher Labs is an open source company. We have a bunch of open source projects. And K3s is just one of a number of projects that we have. We also have a project called Rancher Management Server, which is actually a product. So for us, we don't sell software. We develop software, and then for certain projects which the community has really sort of taken, so that the community likes basically, and based on the adoption, we then offer support for those products. Rancher Management Server is one of those products, and we're in version 2 of Rancher Management Server. Rancher Management Server is a supported product, so it means you can actually pay to get support, but the product, Rancher Management Server, the project, is freely available just like K3s. You can download it, use it. There's no enterprise edition of it. But we can use that to connect with all of our clusters. And so we are moving towards building into Rancher Management Server additional capability specifically for Edge. But right now I'm just going to show you importing a K3s cluster. There will be a number of things coming along. So one of the things is you will be able to create K3s clusters from Rancher Management Server. Right now you can create RKE clusters from Rancher Management Server in lots of different cloud providers. And that's what Rancher Management Server is all about, is running clusters everywhere. So I'm going to go to this import cluster, and I'm going to say K3s import, and we'll create this. This is going to give me a kubectl apply command. I'm just going to copy out that command. We'll go into just make sure that things are running here. It looks like the master is back up. It looks like kubectl is operating. Look, my local path provisioner, we've got some additional things. I've got a service load balancer, most likely running on multiple nodes here, right? Because it's a daemon set. So you can see that in fact, my service load balancer is running on 2 different nodes because I have only 2 worker nodes. But also some other things came up, some other pods came up in the interim while we were talking. What I want to do is run this command here that Rancher Management server gave me. And this is going to install some agents into the system and allow me to get visibility back into the Rancher, into the K3s cluster through Rancher Management Server, as well as use some of the capabilities of Rancher, like RBAC and deployments and things like that. I could obviously do a kubectl apply -f on any type of acceptable Kubernetes configuration. Actually, do I have one here? No. But I did it on this YAML file that's posted through my Rancher Management Server. If we go back and look at what's in that, what you'll see is some RBAC. So you'll see there's a cluster role, there's a cluster role binding. Let me make this a little bigger. There's a namespace, there's a service account. Here's a secret, right? So a bunch of Kubernetes stuff. And then finally, here's a deployment. So I've got this cattle cluster agent. This is how Rancher is able to communicate with clusters everywhere, is by installing these agents. And then they basically set up that 2-way communication similar to the proxy server. And there's a daemon set. And then that allows us to basically have visibility into these things in Rancher. Oh, that made everything bigger. All right. So here's my K3s import. It's still working. Let's see. You can see that my 512 meg on the bottom, you can see I still have plenty of space, plenty of capacity as these things come in, but I'm getting some utilization there, right? Some of those cores are getting used a little bit. 176, 178 eggs. There we go. So that's coming up. If we do the kubectl get pods, we should have some more detail because we're going to start seeing these it's creating the agents now. One of them was a set, right? The node agents are daemon sets. So you can see that those are getting created everywhere. And then I've got the cluster agent, which has just landed on master 2. Waiting for all those things to come up. And once they do, we will have this cluster imported back into Kubernetes, into Rancher Management Server, and we'll be able to see it. And then once I do that through here, we'll wait till it comes up. Let's go back to questions. Once this comes up, we'll take another look at it and see what we can do with it.
Okay, sweet. Let's see. So, okay, here's another sort of roadmap question. This is from Thomas, who asks, are there plans for the ability to run Windows container workloads on K3s?
My understanding is that one of our engineers got, there's now an executable in a .exe version of K3s. I don't know if, let's see, that would be out here. I don't know if, yeah, it's not part of the build process right now, but I know we have done it. And, but the issue is you need, .NET Core containers to run on it. So as far as I know, there's work being done in that area, and there's progress being made. I would check in. This is another thing that I would check in with pound K3s in the Slack user group and see where that's at.
Okay, great, thank you. All right, couple more. This next one is from Ludovic, who says, how do we renew certificates inside the cluster? Do we just restart every node?
Cert renewal. I don't know what the process for cert renewal is inside the cluster. Another great question, Ludovic. It is not something I've done, and I would defer you to the docs, although I don't even know if the docs get us into that. It's worth probably posting that question up through Slack, pound K3s. I'm not sure how you get that done, how you accomplish that.
Okay, no problem. Lots to learn here. So this is okay. So one more. This is from Sorum, who asks. So this is going back to the privileges question from sudo about sudo from earlier. So he says, so K3s can run in a user space with no problems. Systemd can be tackled separately, and I mean without using root sudo at all.
So the question here is, let's see. Yes. So K3s can be run in user space with no problems. So yes, there is actually a project, a part of K3s for no root. Where is that is it in the docs? And I don't know. There is like one individual who really wanted that feature, has worked on it. I don't know the status of it, but it is possible to run it in user space without root.
Okay, all right, cool. That was the last question that has been asked. If anybody has another question, post it soon because I think we'll be wrapping up in a minute. So if there's anything else you want to show us, Mark, and
yeah, sure. Let's take a look. So let's see if we've got some things running here. Yeah, it looks like we have the agents up and running, and we're utilizing 194 megs out of it's probably 400 and shy of 512, right? And then if we go back to Rancher, we should now see. Here it is. Here's our cluster. We can see our nodes. We can see that two of these nodes are marked as masters. They're no execute. And I can do things that I would normally do with Rancher, like deployments and stuff like that. So Rancher creates this wrapper around namespaces for those of you that aren't familiar with it. And I can go in and create a deployment. This is just a UI surfacing Kubernetes capabilities. So I'll just do an Nginx deployment. And we'll do 5 pods just for the kicks. We'll create a new namespace. And I know it exposes 80. And go ahead and launch that. Actually, this I would need to also create an ingress for this because I don't expose my little private network here. So we probably won't be able to actually view that unless we're inside the network. All right, so it's deploying. We should see in the top of this screen, we should see some changes. although there may be too many things. Let's see. Just the Nginx namespace. We can see more utilization down on the bottom one. Those container creating. And let's get them -O wide. Now, I'm viewing this through kubectl. It's only one of them landed on the smaller Raspberry Pi. 4 of them landed on the larger one. And if I go into the UI, I can also see similar things, right? So I can come in and see that these are all unavailable. Nothing's come up. Oh, here we go. One of them came up on the 3A plus. So that's the first one up. So that's pretty much it. That's K3s. That is, Rancher Management Server. We are working on, as I said before, we're working on setting up, building basically a fleet capability into Rancher Management Server. It's not clear right now whether it's going to be a separate project or whether it'll be embedded into Rancher, but the idea is that Rancher will have that you've got all these edge clusters. You're going to have this plethora of clusters, and how do you manage them all? And if you have some, right now Rancher is used because people have them in the data center. They've got them in multiple clouds. They want to manage clusters across providers. That's what Rancher is used for. We're seeing that in the edge with the large number of clusters. There's not really a data center per se, but lots of things to manage and process and to work with in that environment. So that's all I've got. Thanks everybody for joining today.
Yeah, thank you so much, Mark. Awesome job. Thank you for the slides and the demo and the knowledge. And just a reminder to everybody, the session was recorded. I'll do my best to get this out to you all in your email later today, in the next couple hours, just as soon as the video processes. So you'll get the recording and the slides in your email. If you don't see it, check YouTube, it'll be there. You can also reach me on email at matthew@rancher.com or on Slack at Matthew. And all that stuff, that info will be in the slides. All right, that's all we have today. Might see you all tomorrow. We are doing an intro to Rancher Management Server and Kubernetes. Tomorrow, Adrian Goins will be doing that, Director of Community, so should be really good. Otherwise, that's it. Thanks, everybody. Have a great rest of your week. Thanks, Mark.
You're welcome. Take care.